on to presentation by Michael Beims. Yeah, it's titled is actually, why don't you go ahead, Michael? Can you hear me?
Yeah, I apologize for not having the title up front. Yeah, I'm Michael with Engenix.
Yeah, it's okay.
And next slide, please. It's the dust expelling reflector. We'll get into it a little bit more. It's an overview of where we're coming from at Engenix, and we're teamed with Torch Technologies on this particular project. We have a lot of technical capabilities across a wide range, all the way from guidance, navigation, and control to advanced technology research and development. I don't really want to read all of this, but I would like to focus in a little on modeling and simulation as a good bit of where we're coming from. Can we go ahead to the next slide, please? So we wanted the question here, and there's a lot of good information. Thank you for putting this gathering together on how to optimize photovoltaic surface properties to resist damage. That's great. Including actively cleaning the photovoltaic surfaces. We want to bring up one additional possibility, that the photovoltaic surfaces can be sheltered from lunar dust, which raises the question on how to shelter the photovoltaic surfaces. And we're doing a reflective surface that's exposed to the dust, and that allows keeping the photovoltaic surface hidden from the dust. Next slide, please. So yeah, the title is Dust Expelling Parabolic Reflector Technology, DEPART is the acronym. And it does have passive features, treatments that we are seeing in the rest of this get together with a parabolic surface that can reflect light onto a vertical photovoltaic surface. You want to passively treat this, and the reflector surface then will resist the lunar dust abrasion. And active mitigation can be incorporated as well with electrostatic and vibration. And the innovation that we want to expose here is that there's a synergy with the downward force of lunar gravity. So all of these technologies that allow the dust to fall on through or be vibrated loose or be electrostatically repelled loose, it works with gravity.
You have 1 minute remaining.
Very good, thank you. So it'll work with gravity. Our device is open at the bottom so the dust falls on through, and that allows then, we believe, a more effective use of the other technologies. Next slide, please. And where we're coming from is over 25 years experience. I myself am a physicist, but we have subject matter experts in a number of areas. And I want to go to the bottom line. There's more here for reference, but the bottom line is that we're headquartered in Huntsville, Alabama, so we can reach back into a lot of areas with the technology that's focused here. It's, again, thank you, NASA, and thank you, government, for having such a number of qualified reach back possibilities right here geographically. Next slide, please. For contact, some of you around the industry or the community may know Beth Kramer, who's our CEO, and or Joe Eversole, who's our Vice President for Operations. Joe was the contracting officer here at Marshall Space Flight Center for a period of time. And that's the presentation. Thank you very much.
Okay, great. Thank you so much, Michael.